time travel and higher education. We're veterans here from joined last year. I'm Rob Emenaker. I'm the Director of Business Intelligence at Ivy Tech Community College out of Indianapolis, Indiana.
Yep. And I'm Mike Keathley, the Data Warehouse Architect.
So we were here at Join last year. We found Looker about a year and a half ago, I would say. And one of the big questions that we had, and we talked to everybody we could find, was how do you guys actually store and present your data on the back end, and how do you make use of that? We both come from a long background of data warehousing from the Kimball days of where we do star modeling and try to make it as efficiently as possible in traditional database technologies. And how does that change? How do we make the most efficient use of LookML and make sure that we're not cutting ourselves short in any way or not taking advantage of the platform? So we've worked on that for like the past year, and we think we've come up with something kind of creative, and hopefully maybe it helps some of you out that are having some of those same questions. So we'll just kind of get right into it. So a lot of you are probably asking Ivy who, like what is Ivy Tech? Don't know what it is. So we like to say we're the largest college that you've never heard of. So we're Indiana's statewide community college. We have campuses all across the state of Indiana. We are also the largest singly accredited two-year college in the country. So we're America's largest. There are other community colleges that are accredited a little different than ours that may have actually a little bit larger area, but as far as one single accreditation, we are the biggest. We have students from all 50 states. We have students from all kinds of countries that do a lot of distance eds and stuff with us. So we're out there. We've got approximately 8,200 administration staff and faculty. We serve, if you look across all three terms in a college academic year, we have about 170,000 students annually. To give you guys an idea of the kind of the problems that we face, Mike and I, is most of the colleges are four-year peers in our state. Their IT to student ratio, it hovers somewhere around 50 to 60 maybe students to one IT person. We're operating at about 1,000 students to one IT person, right? So when we talk about generating 100 million rows of data, some of you might do more than that, some of you may not. With our small of a team, every data problem that we have is compounded by tenfold compared to any peers that we have in higher education. If some of you are not familiar with higher education, we also have the additional challenge that in this space, in the data warehousing and business intelligence space, we operate about 10 to 15 years behind everybody else. So a lot of the stuff that we're doing here is way beyond anything that they've seen, and that presents kind of its own challenges. So one of the biggest things that we did, Mike, I've been at the college 10 years. Mike, you've been there?
About 2.5.
About 2.5. Mike and I have worked together for a long time. We came from a large pharmaceutical company and before that. And one of the first things we did was, before we found Looker, was to take advantage of Redshift. We were actually the second customer on Redshift, period. So we've been there from its evolution from start to finish. And I'll start this caveat by saying Redshift and the whole AWS platform, it's an amazing product. It really is an amazing product. But it has to fit your style of doing things, right? Like I said, our staffing challenges and our ability to maintain Redshift, it became an untenable thing for us. The biggest thing for us was resizing for storage became very difficult. We, in trying to gather all of this data into our data warehouse, we made some good faith efforts at estimates on sizing for our data warehouse up front, and as you can imagine, we missed those wildly. So resizing a Redshift instance, if you're not aware, requires you to take a snapshot and stand up a new snapshot of that. And if you want to have your data available and not miss any data over the period that large cluster is resizing, you have to have planned ability to move all those deltas over from one to the other, test it all out. This is a multi-month project for just 2 dudes to handle. So we went through this twice?
At least twice, yeah.
At least twice, and we're on the cusp of, we were on the cusp of possibly doing it a 3rd time. And when we came to Looker last year, that's when we talked to some people and found Snowflake, which, as you guys know, separates that layer between storage and CPU. So the other big thing for us is we now have our Redshift cluster at the time when we were migrating over just has way more CPU than we need. It's just way unnecessary because we're trying to meet our storage needs and it's all coupled. So that was another driver for that. Obviously, the segregation of that CPU allows us to do a lot of really flexible things. Allows us to kind of dedicate warehousing CPU to different efforts. It was a better platform for us to do that. The auto scaling was another kind of real huge thing for us too. When we were originally sizing our Redshift cluster and trying to meet the needs of, what do you got, about 1,500 report users? Is that what it is? Something around those lines?
1,500 people that actually use it, yeah.
Yeah, that actually use it. There's probably more than that. And somewhere, I don't know how many reports we have in our current structure. It's in the thousands of user reports and everything.
Yeah. It was like 13,000 last time I counted.
So all of those people, hitting that instance at the same time, obviously with Redshift, we really just had to scale it as large as we possibly could and try to meet those needs, and then we're paying for too much, and it just became a whole thing. So the other thing with Snowflake was allowing us to kind of auto scale to those needs as we need them. Let the warehouse shut down and do its thing when we're not using it. Was a big thing for us too. The other thing is auto optimization, right? So there are manual tweaks that you can do inside of Snowflake, but for the most part, we've found that you can just kind of set and forget the data. Just let it do its thing, right? It will, based on how the data is used and how the data is coming in, it will structure it in such a way that it's pretty much optimal for most use cases. Redshift, we've spent a lot of man hours. You've seen the Looker block for Redshift. We've spent a lot of time in there, just trying to analyze how our data should be distributed. Where our pain points are in terms of sort keys and disk keys. It's a lot of effort, again, for just a couple dudes for several years to do. I do have more team members now. It's gotten a lot better. So how we store our data, let's get into the meat of this. So we came to Looker last year. We're like, what do you guys do? What are we talking? We found Lloyd. We brought him across. He's like, just bring it over as raw as you can. And I'm like, well, dude, that sounds cool, but what does that mean? He's like, just as raw as you can. So we went back and we thought about it. and it's kind of what we did, but we put kind of our own little flavor on it. So we do that. We try to store our tables completely as raw as possible with some audit information on top of that to kind of let us know what the data is doing over time, right? And one of the key differences that we do is we record every record change that happens on every table in our source systems in the destination, in Snowflake, right? So we're not replicating. So if table A changes, the destination does not look like table A. It has every iteration of every record. And I'll get into a little bit of detail why we do this. So say for an example, we have a crafty name table here with 2 very familiar, awesome records in it, named Robert and Mike, okay? And this comes over into our destination table. So what we actually do is we add a couple of additional columns onto this. We tell us what we record what the type is, and then we record the actual timestamp of that record. And then when a change happens in our source system, say Robert changes to Rob, we actually cut a new full record, right? So while we're keeping it as raw as possible, it's every transaction that ever happened in that table forever. So they're the same tables, but they're extremely large. They get very big. The cool thing is with all this cool cloud database technology it's scaling and making these tables big is not a problem. Just throw whole horsepower at it, right? That's the whole paradigm shift for us. So then we decided, okay, we have a lot of customers. We were used to our old structure where we had a traditional operational data store that looked at the data from yesterday. And tomorrow, you lost that. You looked at the data from the previous day. You just constantly are just looking at yesterday's data. Well, I mean, obviously you're losing a lot of capability there if you can't really compare data across time, right? If you can't really see how that data goes across time. Now, there's a lot of ways to solve this in traditional data warehousing techniques. You can, of course, if you know the questions you want to answer, you can certainly build those star schemas and craft your entire data model around the questions you want to answer. Unfortunately, remember that part I said higher ed's like really, really far behind, like 10 to 15 years far behind? Another problem in higher ed is they don't always know the questions they want to ask, right? So we had to kind of anticipate, how do we build a system that's flexible enough, that's not too confusing, that gives them the ability to do this? So what we've done, it really starts with our calendar day table. This is considerably similar to a time dimension table you would have in a traditional data warehouse. It really just stores every days of data. We've committed, we will not give you down to the second, record. We're going to give you day-to-day record changes. We won't commit down to the second, even though we have those transactions. That's just a deliverable that's beyond our needs right now, right? We had to come up with, what are we going to call these destination tables? How are we going to go back in time and violate every copyright law ever made? So, crafty Mike over here said, we're going to call them TARDIS tables, right? So the patent is pending on this. So what does our TARDIS table look like? So for our specific name table, we have a set of SQL that runs every night after our ETL process brings all of our data over. And what it does is it's actually time gating, similar as you would to a slowly changing dimension, all of our source tables. So it's one for one. Every transactional table that we have on our source has a TARDIS table on the destination in our data warehouse with a begin and an end date for when each record is active, okay? And you can, if you're smart and you've seen this, you can see where we're kind of going here. So what we've done, because of Looker's capabilities, is we can shift all of that business logic down to the end rather than doing it on the front in the data warehouse, which requires so much of our time by just doing this. And it gives the users the ability to then look at this data across time, any record across time that they want to. I'm going to try to go a little faster because I'd love to get Q&A in here if we can. So building the LookML, what does this look like? Okay, so for our basic Explorer for name, what we do is we set up an always join on calendar days. We require this, okay? So every Explorer you go into at Ivy Tech will have a calendar day filter on it, right? It's by default set to today. So 99.9% of the users, they just want to know what the record looked like yesterday, right? That's today for us. That's when the ETL process ran, right? So they just leave that alone. Your more experienced users will actually pull in some of those calendar day dimensions. I want to see every month for the past, year. I want to see what, how many employees we had, right? They can do that with this, right? They can put a date range on calendar days and then pull over that month dimension out of the calendar day dimension and over, right? And then all we do is every table that we ever bring in, we join up to calendar days and make sure it's in between that date range, and we're fine. Do your other business logic around it. Do all your other joins around it. Just make sure that every table always touches calendar days and it always lines up. Now, pros to our approach. There's always pros and cons. This doesn't fit everyone's needs. So history is rebuilt every night. It's a big thing for us. So we ran our old data warehouse in Redshift, and we built kind of modern day collections where we were copying records off every day, right, into a table, just shoving them in every day. Problem is as soon as somebody changed a business logic for a record or wanted to add a new field, guess what? They only get that as of today unless we go reprocess for every snapshot date back in history. That became a long process after a while. The cool part is those TARDIS tables, we're killing and filling them every day. We just throw horsepower at it, right? So we've got 450 of them that make up our business logic. We kill and fill them all in about an hour. Okay, date range completely. So if anybody changes business logic at this ETL level or we need to add a new field into this process, it's rebuilt for all of history. We don't have to worry about it. It's completely taken care of. So it's just kind of an ignore it thing. And again, if that process starts to grow as data grows, hopefully Snowflake and those smart guys there keep ahead of us. We feel like they're ahead of us. We're 15 years behind already, so they'll stay ahead of us and we'll never have this horsepower problem. It simplifies our data model. This is really big. It matches the source, right? So one of the things is, if you want to bring a star schema into the picture, it's great, but as soon as you have a problem with something, you got to kind of translate that and feed that back to the source, and how does it actually align with the transactional system? Where is the data problem at? This is really easy for us, right? Every TARDIS table matches every system source table. If a user calls us and says, this field on a report is wrong, I know it's wrong, I can tell you it's in this table, it's for this record, go take a look at it in the source. And if you fix it today, it will be fixed tomorrow because of how we do things. Obviously, it gives you the ability to see and compare data on any day. That was another one. And then this is the big one for us, pushes all of that business logic to LookML, all of it. Now, we do bake some stuff in, and we'll get into that hopefully here in a minute. Cons to our approach requires a lot more horsepower. So as you can imagine, if I set up a star schema approach, model in Snowflake, it's going to run a lot faster than this approach, without a doubt. But it's really the difference between asking my users to wait 45 seconds for a report versus a few seconds, right? They're probably willing to wait that 45 seconds to have this capability and for us to be able to respond to their data needs a lot faster, right? So we just throw more horsepower at it. Requires more storage. So again, with Snowflake, we just don't worry about it. It's S3 costs. They just push it through to us. It's pennies on the dollar. We don't worry about it, but it could be a con to this approach for you if you're money conscious. The other big thing, and this was the biggest detractor for us, was educating our users on this calendar days approach. Like when they see that filter, what does that mean to them, right? It's common for us, we understand that when we change that day, we're looking at the data as of that day. That still for business users can be a hard thing to swallow, right? Especially when you're trying to talk them into comparing data across these days, right? And using that time dimension as an x-axis. So it can get confusing. We just combat that with a lot of training, or we build a lot of canned reports for those said users and let them run pre-generated content, right? The LookML model is definitely more complicated in this approach, okay? The calendar days and joining that all in, the begins and the end dates, there's no question it's more complicated, but we feel that the benefit's worth the effort. We're going to be running out of time, so I don't know if we're going to have Q&A, so we'll have to do this afterwards. But when to snapshot data? So we do have times when we do actually cut hard data that we do not want to change ever, and that's for our regulatory reporting. So we do still have a set of canned tables that we'll select off of our core TARDIS tables that we pull over at points in time like census date or really key regulatory reporting times, and we will just cut those off and leave them alone, right? We don't care what changes. If we report something to the feds, we leave it, right? So there is times and points where you don't want things to be so dynamic. That's why we do that. Static point in time metrics that you don't want to change, things that are really critical, that are feeding strategic plans, anything like that effort that you really need to be solidified in time. And like I said, we just build a separate model, separate set of tables. We populate them once at a point in time and we walk away from them. There's a separate set of LookML that just looks at these tables and can report it out. Use of PDTs, you guys have probably seen this. We were really pro PDT when we first got a hold of it. We thought it was the coolest concept ever, and it's really, really cool until you start chaining those things. And then it becomes this spaghetti, right? So be careful with this, right? You're gonna hear this a lot from a lot of users. We got into this trap. It's awesome for prototyping business logic. So when one of my guys is working for a guy and they just need to write some raw SQL to get something usable, we'll write a PDT, we'll get it out there. It doesn't run very fast, it has to refresh on its own, whatever. And then what we do is we try to, enjoy chaining PDTs, what we try to do is have a review or a bake-in process. So what you want to do is have some period of time when you let these things sit in the business. Is this what you wanted? Did it pass the review process? How often are you using this report? And then what we'll do is we'll bake that probably into our ETL process in the back end. So there is, while we do have those TARDIS tables, we do have some stuff that will run that just makes sense for us to join. If there's 14 tables that join up to make up a student's course information, and that's always how the system does it, like we'll do that on the back end. We won't do that in Looker because it's just a pointless thing to have them the users sit for. And that's it.